Hey everybody, this is Professor Turner with Purdue Polytechnic, and this is a video lecture for ECET 364, Fundamentals of Electromagnetics. Today we're going to be looking at port parameters. These are common mathematical techniques used to quantify and measure microwave circuits and to perform microwave analysis. We're going to look at three types: impedance parameters, ABCD, also known as transmission parameters, and then the one type of port parameter we've already dealt with a little bit in this course, S parameters. And so we're going to kind of fully understand all of these different port parameter types and applications. The course objectives we're going to meet are that we're going to introduce the use of port parameters as a method for describing multi-port networks at microwave frequencies and how we perform analysis of these microwave networks. We're going to do that in terms of the impedance parameters, because you are probably already familiar with the concept of impedance, so it's kind of accessible to you. The second learning objective is that we're going to calculate these transmission parameters. They're also known as the ABCD parameters and sometimes known as the cascade parameters, and we're going to do this for a single network, and then we're going to combine multiple networks together. Finally, we're going to talk about the scattering parameters. These are the parameters, the S parameters, that you're already familiar with through your use of the vector network analyzer. So we're going to fully develop these scattering parameters so you really understand what they are talking about. So let's get into the details of two-port networks. So typically you will find out that microwave circuits are characterized through the use of network parameters. And in the use of network parameters, we've got some sort of device under test. We've got some sort of network here. We call it a DUT, typically, standing for device under test. And that's a very common microwave engineering shorthand. So we've got this device under test, and it's characterized in terms of I/O relationships between all its ports. So we've got this multi-port network. It's got a bunch of terminal pairs that can connect to it. And kind of at its most broad interpretation, port parameters are parameters that allow us to relate the signals at the different ports to one another through some mathematical relationship. So a port in this context is a two-terminal pair that serves as an input and output. It's a waveguide into and out of a circuit, and there has to be the condition that there's a voltage across the terminal pairs, there's a current in, and there's a current out, so that is the definition of a port. So when using network parameters, we can fully describe the functionality of this circuit that's under analysis using fixed and mathematical relationships between all the different ports. And what this means is that if we know the port parameters that describe this network, we don't actually need to know anything about the physical circuitry inside of the network, and that's pretty handy. In most cases, a network is going to have two connections. Usually we consider this an input port and an output port, and therefore these multi-port networks in most applications that we're interested in reduce down to what's called a two-port network. And we'll describe these two-port networks in terms of a specific set of port parameters. So for example, one type of network parameter is the S parameter or the scattering parameters. And in this image, in image B here, what we see is that we can define the two-port network in terms of a matrix of these scattering parameters. So what we do in terms of the scattering parameters is we replace the network with this scattering parameter matrix. For a two-port network, the scattering parameter matrix is going to consist of four numbers, and these four numbers are used to characterize this two-port matrix. So a two-port matrix has four numbers. Multi-port networks have more numbers. This course we're just going to focus on two-port networks. So all of our port parameter matrices are going to be 2 by 2 or 4-element matrices here. We're going to look at these S parameters here in a lot more detail soon, but for now you just need to understand that port parameters are a method to model the operation of a network, a component, a circuit, or a system based on the characteristics of its input and its output. So the question may arise to you, well, why would we do this? And the advantages of the method of these two-port method is that the two-port method, as we'll see, more easily models device behavior that's nonlinear. It's really easy to analyze capacitors, inductors, resistors, and transmission lines. It's a lot more difficult to analyze at RF frequencies, in particular, transistors and such things. So for those nonlinear devices, the two-port network based on measurement is very handy. A lot of times at high frequencies, our conception of voltage and current actually doesn't apply anymore. However, these certain port parameters do, and so we can easily measure these port parameters with lab equipment, even at high frequencies. Port parameters can be combined together in cascade to build more complex systems. Port parameters can be used in analysis, design, and simulation. And also there are a variety of different port parameters that can be used in certain situations to make calculations easier than they would otherwise be. The most common being this S parameter, and the second most common being the ABCD or transmission line parameters. So ABCD parameters, which we'll look at, they're often used to cascade two-port networks, and they're based on currents and voltages. And then S parameters are the ones most often used for RF transmission line analysis, and they're based on incident and reflected voltage and current waves. So no matter the port parameter, there's a basic naming convention, and that is that you've got the port parameter type. So in this case, I'm just indicating that it would be an S parameter, and so that's the port parameter, so an S parameter. And then they have a subscript, and there's two numbers in the subscript, as you can see, and I'll just denote them X and Y. And the first is the port signal is leaving, and the second is the port the signal is injected at. So by injected, I just mean what port is the input port right here. So for example, S12 is the S parameter that measures the signal leaving at port 1 right here when the signal is injected at port 2 right here. So we see the S12 is, the reflected voltage wave at port 1 when port 2 is the sending wave, right? Or sorry, the transmitted voltage wave at port 1 when port 2 is the sending port.